First of all, it's a proper rational function because the numerator has lower degree. And since it's a proper rational function, the asymptote is automatically y equals 0. You get the model, you take the lead term of the numerator that's on there, and simplify that ratio. And you ignore the numbers. You just need to get the sign right. And simplify, though, and you get 1 over x squared, negative 1 over x squared. So now you put that, you indicate on your graph. The asymptote is just the the x-axis. You don't have to draw that. If it's negative 1 over x squared, that means you're approaching from below on both sides. So draw that. Because once again, if I drew that parent, it would look like this. And we're not saying ours looks like this in the middle, but in the long run, it will approach from below on both sides. Then we write that up. We're talking about as it goes to infinity and negative infinity, because that's what we mean when we say long run behavior. And as we go out, we're approaching what y value? 0. How? From below. In this case, it approaches the asymptote the same way in both directions, from below in both directions. Okay? And like I said, we're not drawing the complete graph, just indicating the long run behavior. Now, crossing points. Look in your note sheet and find that which number tells you about crossing points. Number 1, 2, 3, 4, or 5. And read that to yourself. Read number 5. Now, it sounds like a lot. It's not that bad. Basically, you focus on this part here. You figure out when the numerator of the proper rational function is equal to 0. Now, let me go back to our problem. In our case, the thing was a proper rational function, right? So the numerator it's talking about is just the numerator of the whole thing. So write this down. You want to figure out when that numerator equals 0. Basically, the point is the asymptote's x-axis in this case, and so the crossing points will be the x-intercepts. And you find x-intercepts by setting the thing equal to 0. Which you can solve for 0 here. You move the 5 over, it becomes positive. Divide, you get negative 5 over 6. So it crosses at negative 5 over 6, negative 5, 6, comma, what? Yeah, because we're talking about where it crosses that line, the asymptote, the x-axis. Now, in the directions, by the way, it said you can plug that number back into the equation, but usually you don't have to because, like I said, the whole point is it's crossing the asymptote. Apparently right there. Now here, watch this. This is what the actual graph looks like. Write this. We're not drawing these graphs. We're done. You're done writing on number 2. But I want you to see what the actual graph looks like. Now, so negative 1 over x squared is the green part. The blue part's the actual graph. Now look at this. Let me talk about the behavior of this graph. In the long run, you start plugging big numbers in, and it's going to behave like this. You plug in 1,000 and a million and a billion, then you have 1 over 1,000 squared, 1 over that million squared. It's getting closer and closer to 0, isn't it? It's always negative, so it's always below 0, but it's getting closer and closer to 0. Our function does the same thing. You plug in 1,000 here and 1,000 here. 1,000's big, but 1,000 cubed is much bigger. And when you plug in a million cubed is much bigger than a million. Much, much bigger. And so it's the same idea. This part here tells you the long-run behavior. And that's what we see. The graph is approaching 0 from below in both directions, right? That doesn't change the fact that it crosses the asymptote here. And how do we find that? By figuring out when it actually equals 0. So there's two different things. One thing, we're talking about the asymptotic behavior, as x gets huge, it tends towards 0. But to find out where it crosses, you find out when it equals 0. Okay, and they both happen like at different times. All right, let's try number 4. Is number 4 proper or improper? This time because it's not lower degree, it's the same degree, both degree 1. And if it's improper, you do long division. So let's set that up. You can divide x plus 4 into x minus 2, so set that up. Listen to me. A lot of these problems, you have to do long division. Sometimes you could do synthetic, and tomorrow I'll show you how you could use synthetic. We've done that a lot, right? But right now I just want to give you practice doing long division, because you'll need it now. Um, so, look, what you do is you focus on the first term of each. And you ask yourself, what do you multiply this by to match that? Well, the answer is 1. 1 times x would be x, yes? So put a 1 up here in your quotient. If you multiply it through by 1, and 1 times x plus 4 is x plus 4. You put that there. And then you subtract. Now, how you show the work on the subtraction is up to you. There's 2 options. Some teachers would have you go through change the signs and add. So make them, in this case, negative and then add. And that's fine. The other option is to leave the x plus 4 there and just show the subtraction like that. I like writing this way just because then you can go back and make sure you didn't mess up. Like you can see, I multiplied correctly. Whereas the other way, you kind of lose your work, you obliterate your work. So either way, like here, when you subtract, this part goes away, and it should always go away. Negative 2 minus 4 is negative 6. Something. Either way you show the work, you should get negative 6 right there. Listen, we're done because that remainder is degree 0. A constant is always considered degree 0. And it's lower degree than our divisor, so that's when you're done. With the remainder is lower degree. Well, I think both examples I'll do today, it'll just take 1 step, but it could take 2 or 3 steps. All right, now, the whole point of this is now we can rewrite our function as the quotient always goes there, plus the remainder over the divisor. What was the divisor? X plus 4. And look, it's the same process as if you took a number, like let's say I took 73 divided by 2. Well, just watch for a second. 73 halves. It goes in 36 times, by the way. I'm just going to do it really quickly. You multiply, you get 72. Subtract, you get remainder 1. So 73 over 2 can be rewritten as this whole number plus the remainder over the divisor. That's the process we're doing. Okay? So we get a polynomial plus the remainder over the divisor. This is a proper rational function, isn't it? And that's what the notes were trying to say. Where'd it go? The long division will always produce a polynomial plus a proper rational function. Okay? And then, like it says, the polynomial part is always your asymptote, and you find the model the same way we did before. So here, the asymptote is the 1. So put y equals 1. Is that a horizontal line or a diagonal line? Look, y equals 1. Is that a horizontal line or diagonal? Yeah, so circle HA for horizontal asymptote. And then the model, you find the same way. You look at that, simplify the ratio. It's negative 1. You kind of ignore the 6. You do need to get the sign right, but that's our long run model. I'm saying you take the proper rational function, just look at the first term of the numerator and denominator. Well, you get negative 6 over x, which you write that, that's okay, but really the 6 is irrelevant for this. It's negative 1 over x behavior, okay? So you have 4 models. 1 over x, negative 1 over x. 1 over x squared, negative 1 over x squared, okay? And that part right there, simplified down to that model. Now, we need to draw the asymptote this time because it's y equals 1. So draw y equals 1. And then if it's negative 1 over x behavior, that means it's approaching from below on the right this time, and from above on the left. Listen, if I drew the model, it's not normal, it's upside down. And our model would approach from below on this side and from above on this side. Okay? Now we write our behavior statements. As x gets huge, we're approaching what number? Our y values approach what number? 1. It's approaching the line y equals 1. The y values are getting closer and closer to 1. And it's approaching from below on the right side. Oh, one little thing. Notice I put this little arrow right up there next to the asymptote. Don't put it down here under the x-axis because then you'll mess up your x-intercepts. Anyway, what's my other behavior statement? It's approaching 1 still, but how? From above in this case. So yeah, you put a plus sign. Okay? And then the crossing point, You look at the numerator of the proper rational function, which is what? What's the numerator of the proper rational function? The negative 6. Well, you're supposed to figure out when that numerator will equal 0. Negative 6 will never equal 0, right? So this one has no crossing point. And listen, that rule, you need to memorize the rule, but I want you to understand it too. What we have drawn up there, written up there, that equation, that is our function we're trying to draw. Hold on one second. And so I'm saying, look at this thing. We're drawing this function. As x gets huge, this part here tends to be 0. So what you have is 1 plus something that's practically 0, so in the long run it's going to be practically 1. Okay? So that's why the asymptote is 1, because, like I said, as for that huge of x, this part goes away, basically. Tends towards 0, we say. It doesn't equal 0. It only actually crosses that line if it actually equals 1, and the y value, this y value only equal 1 if this part's 0. But this part's never 0. Okay? Where this crosses, the whole graph crosses the x-axis. So this one has x-intercepts, actually. But that wasn't the question. We're trying to figure out where it crosses the asymptote. And so, like I said, it's going to equal 1. It's going to cross the asymptote when this numerator is 0. Okay? So in this case, it just doesn't. All right, do one more. I need to reorder this. This is your number 6, isn't it? Improper again, yes? So we do long division again. So set it up. Put x squared outside the box, or outside the house, or whatever you want to call it. Put the 8x cubed minus 4x plus 3 inside. Squared, I'm sorry. I can't speak. Thank you. True. So what's the first thing we put for the quotient? 2. Because once again, you just focus on the first term of each. You ask yourself, what do you multiply 4x squared by to match 8x squared? The answer is 2. And then multiply everything by 2. 2 times 4x squared is 8x squared. And then 2 times 1 is 2, which I should put over here under the other constant. Right? And then we subtract. So it either change the signs and add or show the work this way. Either way, these subtract to be 0. That goes away, like it should. This just comes down because you have that minus 0, basically. And then plus 1, because 3 minus 2 is 1. Are we done with the division, or we keep going another step? It's the lower degree, that's degree 1. It's the lower degree, so we're done. You stop. If this said 4x squared, you'd keep going. Okay? All right, now, so we're done. So now you rewrite it as that quotient plus the remainder, over the divisor. What's the asymptote? This part, the polynomial part is always your asymptote. So that goes here again. And it's a horizontal line again, so it's a horizontal asymptote. And then this part gives you the model. Once again, though, you just use this ratio right here. Ignore the 4s, you get negative what? Negative 1 over x or negative 1 over x squared? Just 1 over x, because you have x over x squared, which simplifies, yes? It's number 6 on the back. Okay.
Oh, wait. Wait, how can you tell this horizontal line?
Oh, just y equals 2 is a horizontal line.
Yeah, but is it always y equals something?
Yeah, this part here, it's always either y equals 0, or if you do long division, it's y equals this part right here, the polynomial. No, because sometimes what we'll get here, and listen, we'll get to a problem later where what you get here is, well, if you draw y equals x, you get a diagonal line, right? So that's it. then y equals constant is horizontal, always, but it won't always just be a constant. Okay? All right, let's finish this. Draw y equals 2. And if it's negative 1 over x, then it's below on the right again and above on the left, like the last example. I'm sorry, but I want to get through this so you can have some practice in class. Yeah, the quotient is your asymptote. And so you just put y equals in front of it, and either you have a horizontal line or a diagonal line, or you could have a parabola. I'm serious. When you do long division, you could get x squared there. And we won't do that, but you could. I'll show you sometime, but we won't do a problem. Now, look, as you go to the right, we're approaching what and how? Approaching 2, from below. Right? That's what that arrow on the right is supposed to indicate. And as you go to the left, as x approaches negative infinity, we're approaching 2 again, in this case from above. Now, Keith, which numerator we're supposed to be looking at for the next step, for the crossing point? It's the numerator of the proper rational function. What is that numerator? But is it... what my point is, we have two different numerators. This is the one I'm asking you to say. So write that down. Look, the original was not a proper rational function. You don't look at that. You look at the numerator of the proper rational function. And that could equal 0. Move the 1 over, it becomes negative. Divide by negative 4, you get positive 1/4, yes? So it crosses at 1/4, comma, what? No. We're crossing the asymptote. The line is y equals 2, so it must have a y value 2. And listen, if you read the directions, it says to find the y value, you plug it back in the equation. You could, but if you plug 1/4, you would get 2. But why would you do that when you know it must be 2 because it's talking about crossing this line? And so, listen, let me explain this again. In the long run, the asymptote is 2 because in the long run, for huge values, this part tends towards 0. The bigger numbers you plug in, the more closer this part gets to 0, okay? So in the long run, the whole thing approaches 2. That's why this part's always the asymptote. And but at 1/4, if you plug 1/4 in here, you get 0. Well, if this thing equals 0, then the whole thing equals 2, which means your graph crosses the asymptote at that point. So I'm saying there's two different things we're talking about. I don't have that graph, unfortunately. All right, get to work. The odds only are what you need to work on. That's your homework, okay? I say homework, but you should be able to get at least several of it done now. Hold on one second. By the way, was anyone here absent for the test? Okay. Hold on one second. Oh, I totally forgot. That is recording still.